In the first lecture of Poisson process, we discussed probability law of Poisson process. Then we find out the ACF, the mean, the variance, etc. for the Poisson process. And we discussed some properties also, like additive property and difference is not a Poisson process, etc. Now we continue the properties of Poisson process. So the next property is Poisson process has memoryless property, right? We also call it a Markov property. So we are going to prove this now, that Poisson process has memoryless property. So we look at the proof. First I let you the outline, then I will start from here. What actually we are going to prove in this probability, which you can see that I should recall you first that what this xt equals to n represents in Poisson process. This represents the that in the time t2 a number of occurrences are n2, in time t1 number of occurrences are n1, and this is time in time t3 occurrences are n3. That is a standard notation we use in Poisson process. So now we can see what this represent. This represents that in t1 time n1 occurrences are there, in t2 time n2 occurrences are there, and then in t3 time n3 occurrences are there, right? So it is conditional probability कि आपका यहाँ पर एक assumption ध्यान रखिएगा कि t1 then t2 then t3, this is the order, and obviously n1 n2 n3 में भी यही order है कि n3 is greater than n2 is greater than n1, right? So we are saying that this is your first step, this is your second step, and this is your third step. Now we can show that this third step only depends upon this immediately last step. That is the meaning of memoryless property, right? So we will establish this, that this conditional probability, that third step is dependent upon third, second, and first, is actually equal to this slash this only. That means it will depend upon the second, yeah, immediately last step only. So that will be our outline of the proof. I can show you what we will get in the last. We will get this in the last, right? This third or step is dependent upon second step only. So for that we can look at one more step here so that we can start the proof. By the definition of this conditional probability, you know, this will be p a slash b, so it is p a and b. That means t1 n1 t2 n2 and t3 n3. So this will be your numerator and divided by probability of this thing. So that is your probability t1 n1, probability x2 t2 n2. Now these are nothing but this is second order probability distribution, and this is third order probability distribution for the Poisson process. So we will start from here actually, right? Now I go to the start of the proof. Once you know the outline, it is easy to write down your proof. So what we are going to do, as we discussed now, that we will find out second order and third order probability distributions and functions of Poisson process. For that we will need first order as well. So we start with the first order distribution, which is the probability law of Poisson distribution. Sorry, Poisson process. So this Poisson process, definition of Poisson process, probability law of Poisson process is probability x t1 equals to n1 is equals to e raised power minus lambda t1 raised power n1 upon factorial n, right? This gives you the number of occurrences n1 in the interval t1 or the time length t1, right? And this gives you for t2 n2, that means the in time t2 number of occurrences are n2, and that is given by the probability law replaced by t replaced by t2 and n replaced by n2 in the probability law of Poisson process. So now to find out second order probability function or probability distribution of Poisson process, which is given by this, which we discussed कि हमें इसकी जरूरत पड़ने वाली है आगे. So it is probability x t1 equals to n1, probability x t2 n2, right? I repeat कि our assumptions is कि t1 t2 t3, तो T3 इज ग्रेटर देन T2 इज ग्रेटर देन T1। तो टाइम लाइन में आप कह रहे हैं कि T1 पहले है, T2 बाद में है, एंड देन T3 है। और ऑब्वियसली नंबर ऑफ अकरेंसेस N1 N2 N3 अगर आपने ली है तो ये भी असेंडिंग ऑर्डर में होंगी। So now we come again to this probability, second order probability function. So you can write this as conditional probability. As you know, if it is PAB, then you can write this as PB into PA slash B. So that will be used here. So this is probability T1 equals to N1 into probability this T2 N2 slash XT1 N1, right? ये आपको ध्यान है कि this is actually, if you write from this side to this side, that will be easier to understand you. So you can just test ki how this PA slash P is PAB upon PB, and then you have written the PAB's value, right? So it is in the same nature. Now this represents simply that in T1 time N1 occurrences are there, so we can put this value directly from the Poisson law. Just look at this term, and this is what this represents. You said कि T1 टाइम में N1 occurrences हो चुकी हैं, then आगे बढ़कर T2 टाइम में N2 occurrences और होंगी, right? This is the literal meaning of this thing. So what that represents, if we write in the words, that means you are saying that कि this is the difference कि N2 minus N1 occurrences in the interval T2 minus T1, right? So if we can write this in terms of interval, so that will be the thing, right? कि ये जो डिफरेंस है टाइम का, इसमें नंबर ऑफ अकरेंस भी कितनी होंगी जितना इनका डिफरेंस है. सो द N2 minus N1 occurrences in interval T2 minus T1. As soon as we write this, now again we can use the Poisson law. क्यों? क्योंकि अब आपका फिर से बात आ गई कि टाइम में इतनी occurrences हैं, तो you can apply the probability law of Poisson process. So both we can use here now. So now next thing is, this is your Poisson law for that T1 N1, and this is again the Poisson law for your T2 minus T1 N2 minus N1, right? So the Poisson rule you have to write for these two different values of Ta. Now we can collect the things and you can simplify the things in this form, right? So this will be your second order probability function or second order probability distribution for Poisson process. Now we have to find out third order also, as we discussed in the starting of the proof. So this third order distribution you can generalize from this thing. Just look at carefully that we can, how we can generalize this. This was T2, so it will be T3 now, right? E raised power minus lambda T3. This was N2, so it will be highest N3, and similarly this will be T1, then power N1, T2 minus T1 raised power N2 minus N1 into similar term for third will be again there, T3 minus T2 raised power N3 minus N2, and divided by, it will also extend to N3 minus N2 factorial here, right? So this will be your third order probability function. That means this, right? xt1 n1, xt2 n2 and xtt n3. So now we go to that step जिसकी हमने starting में बात की थी, that we have to establish this equals to this slash this only. Now again here in this step you apply the definition of conditional distribution, conditional probability. So this will be PAB divided by PB. So this is a thing, and now you have calculated all these two already. So we put here this third order and this is second order. Now we can simplify these things to get this thing, right? Now we can rewrite it in the form of Poisson law. You can carefully check that it can be written as this e raised power minus lambda T3 minus T2 into lambda. How you can write this directly by this step, or how you have to collect this? It is nothing but Poisson law, T replaced by T3 minus T2 and replaced by N3 minus N2, right? And as we did in the starting to get the second order distribution, you can backtrack that thing. What I mean, that this is nothing but probability law of Poisson process for this T and this N. That means this represents this number of occurrences n3 minus n2 in this time t3 minus t2, and this you again write down as conditional probability. In the to find out the second order, we did this step from in this order, that this equals to this and this equals to this. Now you have to do in reverse order, that this equals to this and this equals to this. So it is nothing but probability xt3 n3 slash xt2 n3. क्यों? क्योंकि आपने डिफरेंस कहा था, इसका मतलब n2 in time t2 and n3 in time t3. So this will be equal to this. So this completes our proof, because we have proved that we started with t3 n3 slash t2 n2 comma t1 n1. तो आपने स्टार्टिंग में कहा था कि ये थर्ड स्टेप डिपेंड्स अपॉन फर्स्ट एंड सेकंड बोथ, but now you are saying actually it depends on immediately last second step only, so it has memoryless property.